is an alumnus of Venu Institute of Technology. He's currently working as a senior project engineer and worked as a cloud operations engineer and cloud platform and security engineer at Wipro. We are happy to announce that this webinar is conducted in collaboration with Mega Club University, KL University, and Wipro. Now let's welcome our speaker, Pradhum and Agrahari sir, to enlighten us on DevOps.
Thank you for the introduction. So, hello everyone. My name is Pradhum, and I just want to know how many of you guys have heard about DevOps or know about DevOps. You can give reaction on the Teams so that I can just, or you can reply in the chat. I just want to know have the idea how many of you guys have worked on different tools and technologies of DevOps. So I'm looking in the chat. Okay, I don't think chat is available for me. So you can give reactions so that I can understand the audience and I can start. Otherwise, I will be only speaking and it won't be like I want you to participate whenever I ask questions. That will give me a little more interactive and not boring.
Yes, sir.
Okay, so I will tell you the flow of the session. So I will start with the DevOps overview. What is basically DevOps and why this thing become very trendy and very useful to the industry. I will cover all the things. What are the different tools and technologies that is used in DevOps, and then afterwards I will touch base on Docker, and if we have time, then we will also cover some parts of Kubernetes. But since it's 1 hour, so I think it will be my agenda and my purpose is to give a glimpse that how these tools, DevOps tools, are boon to the cloud native world. We use Hotstar, and like all the applications running today, Hotstar, all the streaming platforms, and the other and all the e-commerce site, all are using Docker and Kubernetes. So like almost every industry, like in the IT space, like be it telecom, be it banking, are going to use this, and there's migration happening from last 1 decade. From the micro monolithic application to microservices, and then this and then this cloud native domain. Okay, so let's start then. So everyone knows that we are going to be an engineer and we are going to develop and write code and write applications, right? So developer write the business codes, and some are testers. We will test the application, you writing some unit tests or some other function test. And there's a separate team for operations which are responsible for deploying the application on the servers. So I hope you guys maybe heard of water flow model, agile model. So so DevOps as a practice is a upgraded version of these two. So previously we had the waterfall model where the requirement is set at the initial stage, and then it goes through the architects, and then architect build a plan, and then developers write the code, testing is done, and then it is released. Okay, then the agile came when the business people or a business BU are started working with the development team. so that they can change the requirements within the certain time frame. Let's say 3 or 4 weeks, they give a new requirement so that we can make changes, go back, and that use the application, test the application, so that we are not like um, the business team, which are the clients of the developer, are not in the dark. So everything was a little bit, we try to synchronize. Now the DevOps came. So DevOps is basically focused on the release time. Um, so currently, like the almost all the industry is trying to switch to DevOps. So what they are trying to do, they will in the team, generally the team comprises of developers and tester. Now they will also have a team for operations. So what they will do, they will make sure that once the developer write the code and push to the repository, repository in the sense Git. Okay, so I hope you guys know Git, right? So people used to pull the code, write it, and then push the code to the repository. Okay, then so it's a job of operation guys or DevOps guys, which will make sure that that they take from the repository. Hello, sorry, someone is saying something. Okay. Yeah, so it's a developer job. So it's the operation people job to make sure that that it goes in. Okay, yeah. So it's operation people job that that will make sure that once the developer write the code, it will go through a certain pipeline where the code will be tested with the certain test cases, and then it is released to the production servers, and it is available for all the users. Okay, so this is basic thing that is the whole industry is trying to adopt. Okay, so as I told you, like previously the development team was different and the operation team was different, but now the industry is trying to merge both. So I explained you, right? The developers write the code and then there's a Git flow, and then the application are configured. So the operation people will actually configure the servers, right? Because when you write application, there's certain dependencies are there, and let's say the server needs JDK, and let's say if the application is some database, let's say some Postgres or SQL, so they will configure it, and then those will be tested, and again same thing replicated in the production server. So generally DevOps people have a sound knowledge of operating system and Linux, because as I told, like there's a all the configuration has to be done by the operation people or DevOps people. So the code is there, then it goes to server. Okay. So your servers can be on premises or it can be some cloud provider. Let's say AWS, Azure, whatever. You can hire or just book on demand servers to run your applications. Okay. So what are the things that the DevOps people do? So they prepare the infrastructure, and for that they will need Linux basics. And also, like, why Linux is very important, because mostly all the servers are generally hosted on the Linux servers uh, across the world. Okay, so that's why Linux is more important. This should be comfortable with CLI, the shell commands, and Linux file system. Also server management, like server management will also include the network policy, how to set the where to give the permission for the files, everything. And also, like if you have if the application is really big, okay, so then you need load balancers, right? So that it can direct the traffic to different servers. So for which you need firewalls, proxy servers, and different kind of authentication. Uh, so like from a bird eye view, DevOps people generally have the idea about the job of a sysadmin, network people, and the security, because all three are integrated in the pipeline itself, because to make it more automated. Okay. Okay. So let's start with containers. So this is a very useful tool that is used in DevOps practice. So I will also cover in Docker also. So Docker is one of the tools that help us to containerize the application. So what we mean by container, and so basic container is like a packaging tool. Okay, it will package all the dependencies with the application. So one of the tool is Docker, and you can see the graph which like tells like how it picked up by the industry. So almost I think 50% of the companies are using Docker for deploying their application. So you see how much potential it has. So this is a code, okay, and then the no, this is container, and your jar will be put inside the container with the different dependencies. So like I hope you guys know about virtualization, right? Virtual machines. So container is also similar to that, because container will create a isolated environment for the application. I will go to the details of it later on. If yeah. Okay. So developer write the code, send it to server, and how to solve this? There will be some, we have to release the application, right? Once the developer write the code, and then here comes the DevOps people, which will solve the problem. They will be handling the code so that the normal user or end user can use it by putting on the servers. So what they use CI/CD. CI/CD is basically called as continuous integration, continuous development. So we use a lot of tools to do so. One of the tools is, you can see, right? This is Jenkins or Chef. Okay, Chef is this. So that will be used for provisioning the containers or virtual machines. So this is basic basic pipeline, or you can say basic flow, how the code moves to the server. So once the developer writes the code, so the tests will run, then there will be some package manager or build tools that will be used to build the jar. So for Java application, generally Maven is used. Maybe you guys heard of it. Then there is Gradle and NPM. And then once you have the jar, you can use that jar to create the Docker image by listing out what is the dependencies. Let's say if it is a Java application, then you need a JDK, right? To actually run that application. So you have to mention that all the dependencies before using it. Okay, and then once the Docker, so you heard it, right? Like you put all the dependencies and the jar, and it's on the container. So container is basically okay. We will go to with the details. Otherwise, you will get just confused. Okay, so once this jar is packaged with the Docker, so we will have one image. So that image we are going to put into a repository called artifact repository. Okay, so that image will actually contain all the names of the dependencies. Suppose your application is SQL, so it will have the name of the like SQL and the version. Okay, and then the examples of repository is Docker Hub and Nexus. These both are actually Docker Hub is a public. Nexus is for both like community version is there and also enterprise version is there. So, and this whole process is kind of automated because there are scripts written to do all these tasks. And there are certain tools which we can use like GitLab and like generally GitLab is used or Jenkins is used for this job. So if like this is what the code is developed, then continuous integration means like the whole code is built and packaged, okay, and it will be tested on some test servers. So that is called continuous integration. And since every time the developer is writing some code, so we can also say like continuous integration, continuous development. And when the scripts which are responsible to deploy on servers, on production server, will run, so that will be deployed, and that process will call continuous deployment. So plan, code, build, test. Once the test is done, then you can release. So release will basically setting up the environment, and then it will be deployed. Basically, the application will start running. So you can see. So it's a ongoing process. It's never end. Like that's why we have a unofficial logo of DevOps. For waterfall, it's like a stair. If you have gone through that course, software development, I think lifecycle management, SDLC. Okay, so we have servers, right? And we use servers for deploying the application. So it can be on premises or cloud providers. So like I hope, as I know that you guys are from second year, third year. So anyone you can learn AWS or Google or Azure to practice all these tools. And these are the services. There's a lot of services actually: load balancing, clustering, security. So I recommend that everyone should at least use one cloud and like make it thorough. It is really big. Okay, so as I told, like the containers are used to deploy that application. Okay, so whenever application get like more massive, more complex, then there are different modules handling for different things. Let's say one for authentication, one for let's say writing on the database, one for certain things like if you if you can visualize Amazon, okay, then you have a Amazon Pay with a different. Then you can have a mobile categories different. There's a lot of categories, right? So the scope will be divided. That's how the model will be divided, and in the same manner there will be different containers with that with different tasks. So when there is a like huge number of huge number of containers or modules or microservices, then we need something to manage them, because like normal scenarios, like you have the container, you run some command like let's say docker run container name, then you can run that container. But when you have a lot, like hundreds of container, then you need something to orchestrate. Okay, orchestrate. So you use a tool to manage those containers. So for that, we use Docker Swarm. Again, for let's say for 2-digit, we can use Docker Swarm. But when the size get increases, like you see, let's say in hundreds, then we have to use more powerful tool that is called Kubernetes. Kubernetes is basically again a tool which is based on master slave configuration. So there will be master which will be have all the logics written, and it will tell the slave nodes to execute the jobs. So this will basically handle all the your container. Also, so I told you about containers, right? And I told like it started with that you need to learn basic of Linux, because you need to know how servers is configured. And then I started with containers, right? So DevOps people actually have like huge range of responsibilities. So just from getting the code from the developers to the from the Git to the servers, they have also have to monitor like which application, like which model is running. Let's say Amazon Pay Later is not working, or let's say recharge is not working of Amazon. Then there should be some application which will tell, okay, this container is not working, this pod is not working, right? So we use monitoring. So DevOps people also have to like take care of the monitoring. And people use Prometheus or Grafana, and those are really a powerful tool to visualize the CPU consumption and the pod health, everything. The next thing is infrastructure as a code. So you see these two icons. This is Ansible and this is Terraform. Okay, so infrastructure as code. Like normally when we have this, like we use this Oracle box, or let's say we get this new computer, then what we'll do, we will have that ISO file and then we will install the software, right? Everything is done manually, clicks, right? And even in VM also, we generally use this like whenever we used to do it manually. But when there's a large number of VMs, hundreds of thousands of VM or containers, then we need to automate it. So those tools are like the current tools we have are Ansible and Terraform. These are widely used. There are other also. So what it does, like we write the it's a YML based file. Okay, YML is like most it looks like a JSON file. So it's just written. It's just like a key value pairs written, and so it basically very eases out the process of provisioning the servers and configuring with the certain things. Let's say Redis server or JDK, or let's say Python, whatever the underlying interpreter compiler the application need to work. Okay. Uh, okay. Then why it is used? First of all, like they are, let's say it's not a one-time job, because whenever this is done, like let's say uh, uh, the developers once the whole production environment or development was set, then again there's a testing environment, then sometimes there's a staging environment, and every time we have to configure the whole setup. So we need certain tools, and that's why we use these Terraform and Ansible, because if you do it manually, it will be very time consuming and error prone. So if you see this is Terraform file .tf, and it says like, okay, that this is resource key, and then what is AWS VPC, virtual private cloud, and the name of the cloud. So so I recommend also, like Terraform is very useful. So anyone who either know Docker in a very absolute manner, or Kubernetes or Terraform, uh, they can be a huge asset to the project they were working on. We must have to be good with one of the scripting language. So it can be it will be really useful, like Bash, or yeah, you can also work with Python. Groovy is there, then the Golang is there, Ruby is there, but we need the scripting language, because every throughout the whole process we will be writing some scripts to automate the process. So it will really come handy. So it will be helpful in writing the backups, how to write the like automatic backups. You can set system monitoring. You can write the cron jobs. Cron job is basically a scheduled job. You can, it's a small one-line code which will trigger any script with any script with a certain time schedule. Let's say you can set it for like every day 7 a.m. like that. Okay, version control. This is also very interesting. So developer use it version control, but the DevOps will actually handles it. That uh, how to set the versions and how to take the latest one. So so everyone who is in DevOps has the a good understanding of one of the version control. It can be GitLab, Git, or there are also others also. So yeah. So if you see there, these are the like big domain, big domain, which like version control is big domain, infrastructure as a code, Ansible or Terraform. Then for container orchestration, there is Kubernetes. For containerization, we use Docker. For monitoring, this is Prometheus. So these are the like big domains of DevOps, and learning one tool at a time is very useful for any user. And I feel like I was a developer, I think, before moving to DevOps, and like this DevOps will make you complete, I feel like, because you will able to work on different things, like and different tools. Like your job will be very interesting. I feel like you'll be writing the course, you will understanding the system, and like you have a variety of things to try out. So yeah, I just recommend that people should start using these things from the college itself. Okay, so this is the first presentation. I will move to the second one, which is about Dockers. So I told you, right? Like we use Docker for containerization because like for containers, for creating the containers, we use Docker. Now let's see, like let's go in detail and understand like what is container and how it is different from the normal deploying application. So what was the scenario before the containers? So whenever developers write the code, let's say it needs other softwares, let's say Redis and Postgres. Then what it will do, it will install it and then use it, and then it will create a jar and it will write all the dependencies on a text file and send it to someone. Okay. Uh, so let's say there's a person who is working on Linux. It will do the same thing. Now there will be sometimes there will mismatch will be happening because the person is working on Mac will have a uh, different settings, and the Linux will have a different settings. Okay, and the Docker is also I think superseded, or it is more advanced than virtual machines. This is very interesting. I will go through this, so I will cover this. Okay. So let's go with the like small definition, like what is container. So it's basically a way to package application with all the necessary dependencies and config. This is I told you like certain times, so that at least you remember. Okay, that okay, it is used to package the dependencies. So this 1 hour will be over, and like whoever, like let's say 50 people who are listening, they will understand. Okay, there's some tool called Docker which is used to bind the dependencies, and this is really useful. And if people get interested, like they will try out, and it will be really useful when they start their industry career. So this is the JS script, and these are the configs. So everything will be put together. You see, these are Dockers because everything, all the containers is like a complete isolated environment. So it will create a portable artifact, easily shared and moved around. Like we can easily move it around. Uh, I will explain how it is moved around, basically. Uh, so like I'm telling every time, right? Like we will package it and we will create the Docker container or Docker image and put it on repository. But what kind of repository, right? So it is a different kind of repository altogether. You can call it container repository or image repository, where these container or image is generally stored. Generally, it is image is stored, but yeah, sometimes people say container repository, and it can be public or private. Public are Docker Hub, and private can be like you can create it for yourself. Nexus is one of the example you can set it. Okay, so you can search for Docker Hub and you can create one your ID and use it. And what so before containers, everyone has to install this application on their OS to work it. And sometimes there is problem because of the mismatch in the versions of different dependencies. So it is not able to move around, right? Like let's say if you have 100 dependencies and each 100 of it has different version, and sometimes one is updated. Okay, this Mac developers had using the updated version. Then the same code when Linux will try to use, then what will happen? There will mismatch and maybe the application will not run. Certain module will not run. So to solve this problem, container was born, let's say. Okay, so it creates an isolated environment and package all the needed configuration. How it packages, we will go through it. So once the this is created and okay, again it's explaining this what is happening before container. So you see this is list like what are the dependencies and what is the version. Then some dependencies for this database move to the operation side. Okay, and then they are trying to configure server that okay everyone should use it. But sometimes there will be dependency version conflict or some misunderstanding. Then the operation people will think, oh, developer has not written the right code or something like that, because there was a textual guide of deployment. Then people put the developer and operation together so that people can ease out the process. So what it will do, like we have the jar, we will put to the certain repository, right? And we will write the name of it, that this is the application with this certain version. And we will list out all the dependencies also, the name of the dependency in the version. Then whenever the production server or test server or development servers is requires to download it, then they will use that latest Docker file or Docker image. Okay, so Docker image will be a kind of template, right, with all the dependencies. And so once they will take the latest image, then every dependency which is mentioned on this Docker image or template, it will download it from the repository. So that repository is generally called artifactory or artifact repository, because artifact can be considered anything. It can be jar, it can be zip, it can be pip file, it can be all or other dependencies with different extension. Okay, so it's ease of the process, right? Because you have to only download that file, that Docker image, and it has all the required information to move ahead. It's like a DNA. It has all the information, like where to, how it should start. Okay. So this is the container. Container has the config, the jar, and the dependencies. So this is a server, and it need to start it. So what it will do, it will pull the image. It will put the Java app container. So it will basically pull the image. When the image is pulled, the image will be start like with the command we will run it. So that image is a template. Okay, and we will when we run the command, let's say Docker run the image name, then it will become a container because that is a running instance of the image. So that is the basic difference between image and container. I hope this is this will be coming in the later, like in the latter part of the slides. Okay, we have 20 minutes. So container is generally like it's a layer of images. I will show the how they are different layers and how this is very lightweight also. And mostly Linux with image because of small in size. So I told you, okay, that these are like the image will be like is basically layer of images, this container. So Alpine is a Linux based image, ISO. Okay. So these are very lightweight because like when we generally install VM now, we have the complete full OS, which has all the functionality, let's say curl or all the functionality of OS. So the kernel is complete and it can it has a lot of features. Suppose okay, but when we use this Docker, we will always have a base image which will be very lightweight, which will have only certain things which is required to run the application. So which makes them very light because generally this image is some around like 10 to 20 or 100 megabytes. And if you have installed VM, you will see like it's like around 1 or 1.2, 1.5 GBs. So that's how it's very light. So okay. So whenever this you run this Docker, you see that there is command called Docker run, and you give a name of the image. So Postgres is one of the SQL type database. Okay, so Docker run Postgres. So if that Postgres is there, Postgres image is there inside your local machine or whatever the Docker environment, it will not download it. But since it is unable to find the image, so it will download it. And you see there's layers, right? Okay, I will show you like only different layers are downloaded. So I can give you a practical demonstration if time permits. So it will be downloaded in terms of layer. You see there are certain layers. So one will be the Alpine image. So currently it is trying to push 9.6. So suppose 10 points. If you're trying to again after this, you will try to get 10.6. Then not all the layers will be downloaded. Only the change in the difference of the layers will be downloaded. So that is also very makes Docker really fast. Okay, let's come to like what is difference between Docker image and Docker container. Okay. So we have only 1 hour and there's a lot to cover. So maybe I'm speaking or like moving so fast. Apologies for that. So Docker image is the actual package, the actual template. Okay, and that is generally stored in the some kind of image repository, and all the dependencies are also in kind of some artifact repository. But when we actually start the application, so that is called Docker container. And this container are basically used like we need some other tools to manage it once we have a large number of Docker containers. Okay. So if there's command called Docker PS, so it will basically list out all the running containers. Okay. So you can see like it will have a container ID and the image name and which port is open for the like input or output. So you see 10 point when we try to download or run Postgres 10.10, so it says already exists. So it means like it is a layer of images. So Docker was chosen because it has certain things. It was lighter than a VM because of the ISO file is real. The VM use ISO file and they use very light. Uh, it's a OS only ISO file only, but it's a very lightweight because they remove almost all the functionalities. Only the important functionality was being kept in that image or in that particular application. So if it is a image of OS Linux, then let's say Alpine is very, I think it's around 10 to 20 megabytes. Okay, it will explain how it is. So the Docker and virtual machine work on different layers of this OSI, right? So operating system has 2 levels, right? The hardware is abstracted on OS kernel, and then we have applications, right? So whenever we install this VM, then it comes with the OS kernel, right? We can have a Linux, we can install Linux using Oracle box in the Windows machine because it is directly talking to this hardware. I'm not going to type 1 virtualization, type 2 virtualization. I'm just like giving the basics that how it is generally this Docker is lightweight. So both are virtualization tool only, the Docker and the VM virtual machines. But there's difference that VM actually focus on the two things, like they will have their own OS environment. OK, so Windows can have Linux applications running inside the VM. Or Linux will can have a Windows or application application running which requires Windows operating system. But for Docker, it is not like that. It is mostly work on work on the application layer. OK. So because Docker and yeah, since it works on the application layer, so that's why the image is much smaller, the ISO image. And speed is so since it is very light, so it runs very fast, and it's just because of the layer it is start and run very fast. And the third difference is like VM of any OS can run on any OS host. So that's what, like for VM, for virtual machine, Windows system can have the Linux application, some application that require Linux because of it's a complete virtualization. It directly talks with the hardware. We don't need OS kernel. OK. But for Docker, it's not like that. So suppose if the image, the base OS image is of Linux is required for application, then we need the actual Linux machine, Linux server, run that Docker. Also like like there are certain things. So like a Docker toolbox is a tool which is actually used to run the Docker, like Linux based Docker images on Windows kernel. So that is again a tool, but yeah, it is a different thing. So we can install Docker, like it is available. It's for community on the official site. I'm not going to cover that because we don't have time for it. So these are the basic commands: Docker pull, Docker run. So Docker pull will basically pull the image from the repository. See, yeah, we have this architecture, right? I will explain a little bit of this architecture. So this is Docker host, right? And this Docker host basically is it's environment where everything, like this is a Docker environment basically. Like, and we will be this Docker daemon is a basically will provide a shell, like whenever we install Docker, right? So we will prompt to a shell environment where we can write the commands, these commands. So this shell commands or these commands will actually talk to Docker daemon. It's like a load balancer or API server. So that will actually do the job. So whenever this client is like the CLI for Docker, where we have installed the Docker. OK, and then we're trying to connect with the Docker host. So if you're running the local, then the Docker host is the local host only. OK. So once developer write the code, so it's in the repository. That much we know, right? Now we need to deploy it on test servers, let's say. So we have this environment called Docker host, let's say. OK, so some are locally available because it's there, and some will be in the repository because these are newly updated or uploaded. So Docker pull will pull the image from the repository. First, it will try to see that the image is available in the local or not. then it will find then it will download it from registry. And Docker run is to run those application. Run those application means basically run those images. So this image will be converted into a container. So this is a running instance of a image which will act as a complete container, complete application. Docker start is for starting the container, and Docker stop similarly for stopping the container. We can also go inside a container and execute some commands. Okay, we can check the logs. Okay, difference between image and container. I have already explained that part. Okay, so these are some screenshots. So I have that this running. So we have a site called Play with Docker. So that will actually give you a running environment for Docker. So you can guys go and try to use it and learn some commands and play with basically play with Docker. So Docker PS will tell what are the container, what are the images already there. And Docker, let's say pull, then we need to, let's say we need okay, we have this Redis, right? Redis, let's try Postgres. So it download, let's see. It's downloading one by one, the layer. Now we have two images, okay, but there's one running and one is not running because we'll show. If you do Docker PS, you can see only Redis. You don't see the Postgres. Postgres is a database, SQL based. If you do -a, so that will give all. Okay, so we can check, I think there is another command, Docker images. Okay, now we will have it. See, so we have downloaded this Postgres, right? And this is the image ID. So whenever we write Docker run Postgres. So these are very simple commands, and people were using it. You can use it with the command post. Okay, Docker. But when there's large number of containers or image, it's very difficult to manage it. Okay, so database is uninitialized and super user password notified. Okay, so we have to configure it, and we cannot run it like that. But yeah, we can run the Redis. Redis is already running, right? Yeah. So if we go with Docker, yes, we can stop this. I can show a couple of commands. Okay, so its name is okay. So I'm going to stop this container, and then we'll check. Docker stop, and we can give the name of the container. So these name are generally if you don't specify name, so it will be auto generated. Otherwise, you can give name. It is stopped, I guess. Now that we don't have any running container, right? So for running, again, we can run it with the run command, or we can start because we already have a running instance. So we can give the name again, hardcore will be okay. That will start it. We have this container. And now it's so damn easy to install this Docker, and this Docker is complete application. You won't believe, like we can go inside this container and check, like the whole thing will look like a Linux machine. I'm going to run this command, Docker exec is a execute, then it is basically means interactive, and then we can name the container ID or container name. Okay. And then we can give the command. So I'm going to open bin bash. Bin bash will give a prompt to me, a shell environment, basically. We are inside this, inside that, if you see the root at the rate. So this is not node 1. We are inside this Linux machine, which we are calling as a hardcore kill B. See, this is a complete folder structure: bin, data, etc, library, media, everything is there. If you go to etc has so many things like credentials, SSD configuration. If you check, there's a lot of files, right? So the Docker is very easy to download and manage it. Okay, you cannot run Docker over here because we are inside the container. We should exit. So you can, like, everyone can use this. It's free, but you have to register with the Docker Hub first, because you need whenever we run this like this is a prompt, right? This is a shell environment for Docker, and this Docker initializes this environment. Now, whenever we initialize Docker, we need to set the artifact or repository, because when we run this Docker, any command like Docker pull, so it will look for that image. It will look for that image in the given repository. We can download the Python, right? See, the Python will be downloaded within a minute and it will be running. So when we can also go inside this container and run it, and we can execute the Python commands. See, download it. How much time it took? It didn't take any time because it is so lightweight. Okay. And yeah, and this is easier to, and that's why it's very easier to like manage also. Like whenever we have to update it, it can be updated very easily. So yeah, I was telling, like you have to register on Docker Hub, because whenever you give Docker pull and then image some name, it will go to the automatically to that configured Docker repository. So it can be Docker Hub or Nexus, whatever. Okay, so you can use this play with Docker. It's a free lab. Okay, so these are the basic command which I wanted to cover, at least. Here I was. Okay, I was in the slide. So I showed you the start the container, how to stop the container. Docker PSA will list all the running or stop container. Okay, then how to run the pull the image and start the container. So Docker run will do both things, pull the image and start the container. I covered that part. There's a section for port. Okay, so there will be something called port binding. So your machine, okay, your local machine or will have some open ports, and this Docker container is a kind of isolated environment. So that is complete different app, complete different computer. Okay, so that has a number of ports. So suppose we have Redis of 2 versions, 4.0 and 4 and the latest version. Then by default it will bind to the same port. So 6379 is the binded to the, like, this is the local port, not the container port. So we need to change it like for one of them. Otherwise it will give an error. So because of the conflict. So we can set it with the easy, there's very easy commands are there. Docker run -p and the port of this machine and the binding port. And this is -d. -d is like a detached mode. Detached mode meaning, I'll show you guys that. Let's say Docker run that is .geo. Let's see what happens. So it will download and start running. Okay, so this start running. The prompt is gone, the command line. So you have to stop it. Now we can run it again, but with -d is like a detached mode. It will run in the background. You can't open this. Wait. Some issue. Maybe. Try to look for can't open config file. Okay. So you have to configure some other things also to run it like that. Okay, so these are the basic commands which I have gone through. PS and then start and stop. These are the only commands that generally people use it. And I have listed this out. Pull, run, PS, PSA, exec I showed you, stop I showed. Docker kill is to kill that the whole image. It will remove the image. The running container, basically, not the image, the running container. And whenever you set up the environment, you use Docker login. So it will prompt to the repository. When you give the name of the repository, like w.dockerhub.com, then it will give. So you have to give the credentials. Yeah. So these are the basic command. So if any queries are there, I am here to answer. So you can start putting your queries. I can answer.
Sir, is there any difference between DevOps and Agile development?
Yeah. So Agile is like Agile team has this developer and testers. It does not have DevOps people or operation people who are responsible to write the Docker file. So what DevOps is like it's more like a practice is happening. So there's one person in the team which will write the Docker file, let's say, and it will be responsible to look out all the things that has to be covered. The things all I explained, right? But agile development generally didn't have this DevOps people. But what happened, right? Everything is mixed now. This agile team actually have the the DevOps team complete, like 8 and 9 people are like complete team, which will be helping the developer team. But this is not a complete DevOps, right? DevOps means like in the team of 8 to 9 people, there are some developers, there 1 or 2 tester, and there is 1 or 2 DevOps people. This is the real configuration of like how the DevOps team generally looks like. There's a developer and operation working together, not in different teams. But the current industry is trying to adapt to this situation, and the agile team is like working as like normally, though they are being rammed on, or they are being upskilling on these things also. But yeah, there's different teams. Any other questions? you can like ask without like freely. Like I am just your colleague. I'm just two years pass out from you guys. So not, and don't call me sir. No one should call me sir. It's very embarrassing for me. So if we don't have any questions, we will wind up this session, and you guys can reach out to me on my LinkedIn if for anything, or any help or any doubt, queries. Okay, and I hope the organizer of the event will send you a feedback Google form. So yeah, so if you guys give your feedback, and I told in this like to the person like we should have at least 3 hours, because there's a very vast topics, and like even for Docker I have just touched the tip of the iceberg. I didn't show you any demo projects. So ideally should be like I should show you a demo project on AWS running in front of you, and everyone can actually see in their own machine or mobile. So if in future, if we have some time, we'll have one workshop like 3 to 4 hours where I will actually give demo, and you can guys work with me as well. Like practically, we will have a practical demo session. You can also try it out at the same time. Okay.
Guys, we have shared the feedback form in the chat box. Kindly please do share and do fill the form immediately.
Thank you then. All the best for your upcoming placement, and for second year, try to do more projects and complete projects, not just taking from the GitHub and trying to make it run. Okay, try to do some actual work because the projects will only help you guys. So, and try to do some open source project, because that will give you more understanding how actual concepts are applied. Because when we write the project, or we don't take care of the design part. So when you start contributing to the open source, you will able to learn how big applications are actually designed, like how the modules are being segregated from each other based on the scope. So yeah, that's all my suggestion to you guys. Okay, thank you for listening very patiently. We'll take a screenshot for my sake. Thank you then. Have a good day. Bye.
Yeah, thank you so much.
Every day holds the possibility of a miracle. So keep hoping for the best and keep shining. On behalf of our entire NGC club and VRT, I would like to thank our honorable speaker. Thank you for inspiring and encouraging us with your words on this special day. And last but not the least, I would like to extend my gratitude to our audience for coming and making this webinar a successful one. Thank you.
Yes, thank you for sharing your knowledge.